Most times, simple problems involving the application of Ohm's law may not be as simple as it is, especially when such problems involve network of circuits or mesh of circuits that have different junctions or joints. Where Ohm's law fails, that is where Kirchoff's laws pick up, right? I repeat, where Ohm's law fails in calculating problems involving electrical circuits is the point Kirchoff's laws pick up and progress with it. So we're going to look at two statements. The first statement is Kirchoff's current law, all right? Then the second one is Kirchoff's voltage law, right? So we are going to look at Kirchoff's current law. Very simple. Kirchoff says that if we have currents from different direction, current, call this IA from a direction, call this IB from another direction, right? And there is another one from this angle, call it IC from this angle, right? That this point J, okay, is a junction where these currents will meet and then flow out. That's what Kirchoff's current law is all about, and we call this ID, right? It flows out. So, by Kirchoff's statements, Kirchoff is actually a German scientist by name Gustav R. Kirchoff. He was the one that laid this foundation in the first place, so that we'll be able to solve problems beyond just ordinary the application of Ohm's law. So what is the meaning of this? He says that the algebraic sum of these currents, okay, flowing into a particular joint is also the total current flowing away from that joint. That's what it says. So if we represent algebraic sum of the currents I, okay, I represent elements of current, okay, flowing as this is equal to the total current moving into the joint J, and J is also equal to ID, which is the current moving away from the joint. So that's what Kirchoff is all about. And if we do that, it simply means that IA plus IB plus IC all equal to J, and this J is also equal to ID. This is simple, the illustration of Kirchoff's current law. I'm talking about Kirchoff's current law, right? That is it. So if we now say, for instance, we say that IA is equal to 2 amps, okay? All right? And when I say IB is equal to 3 amps, but we don't know the value of IC, which is unknown. IC is unknown. Let's see what happens. Unknown. We don't know the value of IC, okay? If we have that the total current flowing away, ID is equal to 12 amps, we can easily find the value of IC by making IC the subject from this. So if we make IC the subject, becomes IC is equal to ID, right? The total current minus the sum of all the currents, right? Which is current A plus current B. That's what it means. And the quickly we have, IC is going to be total current 12 minus brackets. Current A has the value of 2 amps, current B value of 3 amps respectively. We have 2 plus 3 close. We equally continue with that. IC can now be 12 minus 3 plus 2 is going to give us 5. Therefore, we now see that IC, current IC is equal to 7 amps. Okay? 7 amps, that's what it means. It means if we substitute the value of this current with 7 amps, we are going to get a total current flowing away from the system as 12 amps. That is what it means. Very simple. Alright? And that is a very wonderful way to present Kirchoff's current law. Alright? Now, if that is the case, we can state that J is equal to I D, meaning that J is equal to I A current, A plus I B plus I C. If we have all this and we want to find J, this becomes, this is 2 amps, this is what, 3 amps, and this is 7 amps. What this means is 2 plus 3 is 5, and 5 plus 7 is 12 amps. Therefore, J, the total current at this point, is actually 12 amps. That is the current value, leaving the entire junction, okay? Leaving away or flowing away from the point. That is what Kirchoff said. Very, very important, please. Current does not accumulate. Does not accumulate. Okay? Accumulates at a point. Current does not accumulate at a point. Please, let's take that note. Very, very important. So, what I mean is this, all this current flowing and meeting at this point will not remain here. They will meet at this point and flow away. There must be a way of flowing away. That's what it means, and very, very important in solving anything that has to do with Kirchoff's current law. By the time we delve into different types of electrical circuits that need the application of Kirchoff's laws, both current law and the voltage law. Alright, thank you for watching up to this moment, and I want to urge you, in my next class I'll be treating voltage law. I'll be treating this law. So stay tuned and be connected to this channel. You will learn a lot. Remember to give us some thumbs up. Alright? Share with your students, friends, and networks. Put on the bell button